My name is Rafel Domenech, and I'm Technical Project Manager here at LORIOT. My job is to coordinate and align all sides of a project so that our engineers have all they need to deploy in time, and our customers are all in the loop every step of the way, while we're also understanding what is required from their side. So today, Today, I want to talk about some important aspects of what to consider when planning a LoRaWAN project. From the first concept, like in point 1, to carefully analyzing and planning the architecture in points 2 and 3, to choosing the right components for the project in points 4 and 5. Most of the points I will make, you will probably already be familiar with in some form. You could probably consider them common sense, but still, I think it's important to always keep them in mind, especially when first entering the world of IoT and LoRaWAN. So every project begins with an idea, with a new idea or a requirement. Maybe you came up with an idea for a new project, maybe a new opportunity opened up. Maybe your company's management decided that it's time to leverage the advantages of the Internet of Things, or maybe it was one of thousands of other possible reasons that led you to this new project. Whichever it is, you must be able to clearly define the goals of the project. Are you looking to increase the efficiency of a process or to boost the productivity in a specific area? Are you looking for ways to gather additional data so you can better understand an issue, etc., etc.? It's imperative that you understand the goals of the project, because this will enable us to identify the use cases. And every use case will have different requirements, and it's important to be able to identify which aspects are the most critical, which are not essential, and which ones might cause you trouble down the line. And lastly, you need to be fully aware of the intended scope of the project. So are you just planning a small proof of concept in your home lab, or are you planning to cover a large area, a factory, a city, maybe even a whole region? And how long are you planning to keep the project running? Are there any plans to expand the size of the project in the future? All this will play a role in how you design the project. So once you've identified your use case, the next step is to identify the right technology for it. As my colleague Yannick Kopp already showed us, there are many wireless technologies available. Some of them have similar characteristics, but all of them have their pros and cons, and each of them has a niche where they excel at, right? So for example, let's say you want to send wireless data over very short distances, and power consumption doesn't play a role on your use case, and maybe NFC or RFID are possibly the best options for you. If you want to send wireless data with high bandwidth in your office building or at home, then Wi-Fi is the logical choice. And however, if you want to send small packets over long ranges from battery powered devices, and you want to have your own infrastructure and have access to a rich ecosystem of manufacturers, then LoRaWAN is your technology, hands down. So, of course, this doesn't mean that you have to choose only one. Your project may have use cases that require a combination of these technologies. This is a very important point. They are not competing against each other in the sense that it has to be one or the other. In fact, they complement each other. And you actually stand to gain the most out of them by combining them very wisely. So for example, just like your smartphone combines GSM and Bluetooth and Wi-Fi connectivity for different tasks. And I probably don't need to tell you how important smartphones are nowadays. So this is a very good example of how combining these technologies might actually give you an even better result than just sticking to one, right? So let's assume you have identified LoRaWAN as a technology that best suits your needs. And let's take a quick look at the architecture of LoRaWAN. My colleague also showed a nice overview. This is a similar slide. Here we can very quickly see that there are many components involved, from the sensors to the gateways to the network server, the application server, and finally the applications themselves. It's important to identify which of these components are already available for you and which ones need to be procured. So obviously, the sensors and the gateways and network server are necessary in order to receive the sensor data, but you will also most probably need to identify what tools you need to use in order to process the data so that you can access it and visualize it in your application, right? So it's important to define which communication protocols you're able to use for the communication between the network server and the application server, because you will have the data you receive from the sensor made available from the network server, but you also need to transfer this data to your application. So you also have to keep in mind that your project doesn't exist in a vacuum, and that you have to make sure that your preferred protocol for this data connection is actually being used in the ecosystem. So it's not some obscure or niche technology. So, for example, very common technologies would be MQTT or WebSocket, TLS sockets, all those technologies that are very common. If you are using that, then chances are very, very high that you will have no problems in this regard. Sorry, let's go to next. Lastly, you should also carefully consider how you want to deploy your solution. Do you want to deploy it in the cloud, or make it available on the web for your colleagues or customers, or maybe you prefer to keep it completely in your own network and data center? Or maybe the best option for you is a mixed approach. Maybe you want to have the network server on premises in a closed network that nobody can access except you, but for your business you require your application to be on the cloud because maybe you have an Android app and you need to be able to draw the data from there, for example. So it's up to you to consider the pros and cons of each option and choose which one works for you the best. Of course, there are also solution providers that will take care of the complete vertical, so end-to-end providers. And you will see some of them in part 4 of this webinar by my colleague Carles. So something that we must always keep in mind are the limitations of the technology. Even under ideal conditions, there will always be some level of restriction, sometimes very trivial. And it's important to set realistic expectations. So all hardware has physical and technological limitations. For example, there's a bandwidth to LoRaWAN packets you cannot exceed. If a gateway is only half duplex, then physically it cannot receive any packets while it's sending at the same time. And there are other restrictions like the duty cycle, which is more of a legal issue that you cannot exceed it either when you're using an unlicensed frequency band, etc. There are many other ways that restrictions may apply. But you also need to expect external factors having an impact on your project, and that ideal conditions will never occur. So some of you may already know the current world record for LoRaWAN is at a distance of 766 kilometers using a stratospheric balloon. But you will never be able to achieve those ranges on the ground because the line of sight there is more than ideal. The curvature of Earth alone will already impede you from reaching that length, and that is without taking into account buildings, trees, and other obstacles that will just decrease your range. So in this case, it's a simple physics that just don't allow you to have an infinite reach. And for similar reasons, you should also always make sure to have a level of redundancy. So if an application is critical, you cannot have just one sensor or one gateway covering it. So electronic devices, they can and will fail at some point. It's the nature of things. So you need to make sure your infrastructure has a fallback mechanism in place, so that operations can continue without interruption, even if one of them fails. And equally important, if not more so, is to follow the laws, guidelines, and standards that govern these technologies that you are using. So, for example, the LoRa Alliance publishes the specifications to ensure everyone is following the same standard and that the ecosystem remains compatible. The ETSI, the European Telecommunications Standards Institute, establishes some limitations to the use of unlicensed frequency bands to avoid abuse. And depending on the region, those might apply differently as well. So even when you think you've got all these things down, you still need to make sure that you follow the industry's best practices. So even if it's technologically possible, you shouldn't be overloading one single gateway with thousands of messages at the same time, because then it will just not work. Or you need to make sure that a sensor is not blocked or obscured if you want it to operate correctly, and to make sure you only buy LoRaWAN devices that have been certified by LoRa Alliance, and so on, right? And I know this is a lot of things to keep in mind. So if you feel overwhelmed or lost in this tech jungle, so don't be afraid to ask or seek third-party advice. There are many companies that specialize in consulting, and most manufacturers or network server providers like LORIOT. We can also give you advice if you require it. So don't feel afraid to ask. That's important. So once you've gained a good overview of your requirements, you can start looking for the right hardware for your use case. So there's a multitude of vendors and manufacturers for all kinds of purposes and use cases. So you need to know when selecting a device, for example, will you be retrofitting an existing installation, or are you buying completely new devices? Do you know what LoRaWAN device class makes the most sense for your use case? You also need to keep in mind that there are many different technological approaches to solve one in the same use case. Let's say, for example, there are parking sensors that use radar technology, and others that use magnetic sensors for the detection. Or another example could be people counters. They may use Wi-Fi and Bluetooth detection of your mobile devices, while others will use radar again, or others will use infrared, depending on the manufacturer and the model. So you need to decide which device will make the most sense for your use case. Again, just always keep in mind the advantages and disadvantages of each. Similar case applies to LoRaWAN gateways. For example, is your gateway going to be set up indoors or outdoors? How are you going to connect the gateway to the network server? Via an Ethernet connection or via GSM with a SIM card? So there are some things to consider. And again, if you feel lost in a sea of choices, ask for advice. We at LORIOT work closely with many of the market's most trusted vendors and manufacturers, and we will gladly point you in the right direction if you ask. So, and well, finally, you will need to choose the LoRaWAN network server type that best suits your needs. So maybe if you're looking for a cloud-based solution, you will find community servers for hobbyists, and also managed for professional servers. There are on-premise options if you want to run a private instance in your data center, and there are hybrid models which combine cloud-based and on-premises deployment, as I mentioned before. Well, and of course, in my opinion, the right choice is LORIOT. How could it be different? And we offer all models, from free community network servers where a user can just register for free and start tinkering away, to professional cloud-based servers managed by us, and private instances both in the cloud or on premises. My colleague Ellen Ray, just after this, will go a bit more into detail with this. However, if you're curious, feel free to go to our website and register a free account on any of our many public servers we have. And yes, that would be all from my side. Thanks for listening, and back to my colleague Yannick Kopp.
Okay, perfect. Thank you very much, Rafel.